Alright, trig packet part 1, we're going to start getting into trigonometry. So when we're given a right triangle, we have three things, okay? We have our hypotenuse, we have our opposite side, and we have our adjacent side. Adjacent means next to, opposite is across from, and the hypotenuse is opposite of right angle. So that's what we're really looking for. Alright, and this is called our angle theta. So if we're looking at this angle, hypotenuse is always going to be opposite the right angle. So this is the hypotenuse, which is 15. What is the side opposite to theta? Well, opposite of this, well, that's across from here, so that is going to be 9. And then next to, well, here's theta, next to theta is 12. Okay, so the hypotenuse is 15, opposite is 9, adjacent is 12. When you look at the second example here, same thing, we're still looking for these. Alright, now the only thing that we did is we changed our theta, which is up here. Well, hypotenuse is still across from our right angle, so the hypotenuse is still 15. Opposite, okay, well, opposite of this angle is across from it, which is 12. And adjacent is now next to it, well, next to this is 9. So now we have 15, 12, and 9. Alright, the above two examples show that the reference angle causes the opposite and adjacent legs to switch roles, whereas the hypotenuse remains the same. So if you notice, the hypotenuse didn't change, it was 15 in both of these, but since we changed our reference angle, the opposite leg and the adjacent leg switched roles. So now when you're given this, now instead of having numbers, we have letters. So what is our hypotenuse? Well, here's our right angle. Opposite the right angle is letter C. What is the opposite side to theta? Well, you have to look at that. That's down here. Alright, opposite side is across from that, which is letter A. And what is opposite of the angle A? So here's our angle A. Opposite angle A is over here, which is B. And which side is adjacent to that? Well, adjacent is right here to that reference angle, which is A. Okay. Now, just looking at these, now all we're going to label is hypotenuse, adjacent, and opposite. Well, we know that here's our right angle, hypotenuse, opposite the right angle. Here's our right angle, opposite the right angle, hypotenuse. Here's our right angle, opposite the right angle, hypotenuse. Here's our right angle, opposite the right angle, hypotenuse. Now we can go to adjacent, or we'll go opposite. So here's theta, opposite. Here's theta, opposite. Here's our angle. That side's opposite. Here's our angle. That side is opposite. Which means the last one's going to be adjacent. So if this is our angle, this is adjacent. If this is our angle, here's adjacent. It's next to the angle, next to it. And here's our angle, so next to it. So notice that the adjacent angle always has two sides next to it, but one of those sides is the hypotenuse. So the other side is going to be the adjacent one. So now, given a triangle, fill in the blanks. The hypotenuse, well, that's here, which is 10. The adjacent side, well, that's this angle. Adjacent is letter P. The side adjacent, well, that's this one down here. Adjacent to this, well, we know that this is the hypotenuse, so this has to be the adjacent one. 7. P is blank, so P is adjacent, and blank to this, well, and opposite. What is the length of side P? That is a good question. Well, what we know is we have our a squared plus b squared equals c squared because we have a right triangle. So we have a squared plus 7 squared equals 10 squared. So a squared plus 49 equals 100. a squared equals 51. So we take the square root of 51, so a is equal to the square root of 51. And that's how we figure out what a is. We use the Pythagorean theorem. So the Pythagorean theorem will give us that. Now we get into something called sine, cosine, and tangent. Alright? The phrase sine of angle theta is abbreviated, and sine theta means that the ratio of the opposite side to the hypotenuse. In other words, the sine is this ratio which is opposite over hypotenuse. So it's our opposite over hypotenuse. So to get sine, we have to find the opposite over hypotenuse. So when we look at this, okay, so opposite here's our theta opposite is 3, hypotenuse is 5. So the sine of theta is 3 over 5. We're just doing opposite over hypotenuse. And then when we look at the cosine of angle theta is abbreviated cos theta. It's the ratio of the adjacent side to the hypotenuse. And so it's cosine over the adjacent side over the hypotenuse. So it's adjacent over hypotenuse. So when we look at our angle, adjacent is going to be the 4, and the hypotenuse is still the 5. So now our cosine is 4 over 5. And then we can use these to actually determine the measure of the angle, which we'll do in a little bit. So when we move on to example 3, the tangent. Alright, so tangent is going to be opposite over adjacent. So now we have opposite over adjacent. Well, if here's our angle, opposite is 3, adjacent is 4. So to find the tangent of the angle, we're going to do opposite over adjacent, which in this case is 3 over 4. Okay, so if we have this triangle, we want to find the sine, the cosine, and the tangent. Well, if we know that sine is opposite over hypotenuse, opposite is going to be, here's our angle, opposite is the square root of 8. The hypotenuse is 3. So that's how we get the square root of 8 over 3. The cosine is adjacent over hypotenuse. Well, here's our angle. Adjacent is 1. And the hypotenuse is still 3. And the tangent is going to be opposite over adjacent. Well, opposite, adjacent. So you get the square root of 8 over 1. And that's how we figure out these are 3 trig ratios. So we have sine, our cosine, and our tangent. So when we have this, we need to use the Pythagorean theorem to find the unknown side. So we want to find this side. So our Pythagorean theorem is a squared plus b squared equals c squared. So we have a squared plus 2 squared equals 3 squared. So a squared plus 4 equals 9. A squared equals 5. So a is the square root of 5. So now we know that this side is the square root of 5. So given our angle, we can say that this is adjacent, this is the hypotenuse, and this is opposite. So now we know the 3 different sides, what they all are. And now we can figure out, well, so the hypotenuse is 3, opposite is the square root of 5, and the adjacent is 2. So we label them all in. So sine, so going back to a couple pages ago, sine is going to give us opposite over hypotenuse. So sine is opposite over hypotenuse. So we go opposite, which is the square root of 5, over hypotenuse, and a hypotenuse is 3. And cosine is adjacent over hypotenuse. So we look for the adjacent, which is 2. Hypotenuse is still 3. And tangent, so tangent is opposite over adjacent. So the tangent opposite is the square root of 5, and the tangent is 2. So that's how we come up to all of these values. So that's how we get all of these in our triangle. So when we look at these next examples, okay, it says find the sine, the cosine, the tangent. Well, the first thing you have to do with these is label them. So you know that hypotenuse, opposite, adjacent, across from the angle, next to it, across from the right angle. Hypotenuse, opposite, adjacent. So to figure out our sine, the sine, alright, opposite over hypotenuse, opposite is 5, hypotenuse is 13. Cosine, adjacent over hypotenuse, adjacent is 12, hypotenuse is 13. And the tangent is opposite, which is 5, over adjacent, which is 12. So that's how we get all of our values. So the key thing here is you need to remember sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So all I'm doing is just filling in all of my numbers. So when I look at the next one, so sine, opposite over hypotenuse, well, opposite is 6, hypotenuse is 10. Cosine is adjacent, which is 8, hypotenuse is 10. Tangent is going to give me opposite 6, adjacent is 8. So we can label this. So hypotenuse, here's my angle, so this is adjacent, this angle is opposite. So now we just label our sine, which is opposite over hypotenuse. So opposite is the square root of 13. Hypotenuse is 7. Cosine, adjacent, which is 2. Hypotenuse, which is 7. Tangent, which is the square root of 13 over 2. And we can continue this for the next triangle. So we have here hypotenuse. Here's my angle, so this is adjacent. This is across from the angle, so this is opposite. So my sine is going to be opposite over hypotenuse, which is 40 over 41. Cosine is going to be adjacent, which is 9 over 41. And tangent is opposite over adjacent, which is 40 over 9. And to move on, we'll do these last two real quick. Right angle, hypotenuse, angle opposite, angle adjacent. So the sine is going to give me my 1 over the square root of 5. My cosine is adjacent, which is 2 over the square root of 5. And my tangent, which is going to give me 1 over 2. And this last one right here, here's my right angle. So this is the hypotenuse, this is the adjacent, and this is the opposite. So our sine, and we will finish this up. So our sine is equal to opposite, which is 3, over our hypotenuse, which is the square root of 18. The cosine is also 3 over the square root of 18. And the tangent happens to be 3 over 3. So that is just writing all of our ratios.